The big picture, the one sentence you should memorize. This app is a user space program that turns remote database events into cache, reactive UI state using deterministic data flow, atomic backend operations, and declarative navigation, with clear separation between build time configuration and runtime behavior. Later, we will expand on the build time configuration and runtime behavior. But basically, you can think of database as just a remote accessing your I mean sending events to your front end Flutter, and your Flutter has a reactive UI state using deterministic data flow and atomic backend operations, and declarative navigation using your routes. Everything else explain why that sentence is true. How this relates to all our previous discussions, you asked earlier about CPU pipeline, program counter, JSON parsing, atomic database updates, read modify write bugs, DUGs, nodes, memoization, event versus state, emit, cache versus recompute, Redux slash Riverpad slash React diffs, Supabase real-time, and WAL. This Flutter app is the same ideas, just one level higher. Here's the mapping. Earlier concept, program counter, where it appears here, Dart VM instruction pointer, hidden from you. So there's a Dart instruction when we initialize the app, when we run Dart run and then connect to the main. There's a Dart VM instruction pointer that actually acts as a program counter. CPU pipeline. So in terms of CPU pipeline, we have Dart entering a native /JIT/AOT to machine code, kind of like a program counter to fetch instruction to executing units. JSON parsing, Supabase client decoding HTTP responses. Atomic DB ops, update profile set where ID equal sorry, JSON parsing, basically Supabase client or your user app or the browser decodes HTTP response and then return to your app. Atomic DB ops, so the update profile set where ID equal so that's a declarative that provide an atomic uh it provides an atomic behavior. Lost update avoided by DB side atomic updates. So the database inherent property such as the PostgreSQL or the such as the PostgreSQL are handle these atomic updates, or prevent the loss update that happens in their app. So in our app, that could look like a random bug or a random event that could not be controlled. So because of PostgreSQL in the backend avoided that, we are not encountering that in the front end. DUG, so the direct acyclic graph are similar to Riverpad provider graph. And actually, this is what Riverpad use under hood. A node in that DUG, direct acyclic graph, is the provider in this Riverpad provider graph. So each node is a provider. Memoization, Riverpad caching provider results. So if the request was not up, or the value was not updated, Riverpad cache the result. That's memoization. Application in Node. So that's what Riverpad, you know, cache the provider or the node results. So you can think of that as river pad as caching the result or the value of the node in a graph database. Emit, Supabase sends auth or state changes. So the Supabase send auth or state changes to the client, which is the browser and then your app. Event, auth change, button press. So one event is could be a two values, like an imperative control that triggers another values, which is has a bit dependency, like an auth change with a button press. State, provider output. So a state is what the provider returns as a result. So that's the kind of like this riverpad caching. So depending on what it would return, so that's the current state, whether it returns the old value or a new value. Diff, Flutter widget rebuild. So let's say you want the rebuild. So the rebuild will only happen after the routes, the authentication, the routes, the riverpad, and then UI. So after those, if we could say that it's kind of like with React with the DOM model, if the widget rebuild and cache, riverpad plus image cache. So that's literally cache applied to riverpad concepts. Cache, while Supabase real-time triggers. So the wall in the backend provide like a Supabase real-time triggers. User space, your Flutter app, not CPU, not kernel. So your Flutter app is a user space, even though it's using Dart language, programming language. So nothing you learned earlier was wasted. You were just zoomed in too far. Build time, second, build time configuration versus runtime behavior, critical for assessment. This is one of the most important distinctions in your entire project. Build time configuration decided before apps run. Example in your app, static const supabase URL equals string dot from environment argument code supabase underscore URL semicolon. What this means, value is injected when building. It becomes a constant in the compiled binary. So you don't inject this after you build because that's where it's already a compiled binary. You inject it during the build or before the Flutter run build. It cannot change while the app is running. It is used for security plus environment separation. When this happens, Flutter build web uh, backward slash uh, backward slash next line dash dash dart dash define equal supabase underscore URL equal dot dot dot.